Some terms are called like terms. What kind of terms are these? Well, they have two requirements to make like a checklist with the requirements. So the first requirement is that those terms that we call like terms, they have to have same variable, or I should say same variables, because some terms, as you remember, may have several variables. Same variables. And then those variables have to have same powers. Same powers or exponents. I'm going to write down several examples, and then we're going to try to see if those terms are like terms or not, or they're not. So these are the examples. We're going to try to go over each pair of terms and see if they're like terms or they're not. So as we do that, maybe pause this video and for each, and then try to guess what the right answer is, and then let's check what I say. Now, the first pair, 5y and 7y, are these like terms? We have to check both requirements, so they should happen. So first, same variables. Do we have same variables here? Well, yes, we do. I was going to say no. We do, y and y. Okay, so check mark for the first requirement. And then second requirement, same powers or exponents. Are these two variables raised to the same powers? They are. Well, we can say they both don't have a power visible. It's technically power 1, but we can see that it's the same. So are these like terms? Yes. How about the next pair, x cubed and negative x cubed? Asking ourselves same questions. Are these the same variables? Yes, x and x. Do they have same powers? Yes, x cubed, x to the third power, x to the third power. So that makes them to be like terms. Yes, they are. Next, 10x squared and then y, and then 10y cubed. Going over the list again, are these the same variables? No, right? So this time, this term has x and the second term has y. So these are not like terms. We don't have to check their powers. If we notice different variables, then automatically these are not like terms. So no, these are not like terms because variables are different. And then the last example, 2x and x squared. Okay, first requirement. Are these the same variables? Yes, x here and then x here. Good. Let's move on to the next requirement. Do they have same powers? No, they don't. So this term or this x has power 1 or power is invisible, and then this variable has power 2. So different powers, different exponents. So even though they are same variables, but because powers are different, these are not going to be like terms. And now the reason why we want to learn about like terms, or I should say why we want to identify like terms, is because like terms can be combined. We can combine them together, like add or subtract them. So how do we combine like terms? How to combine like terms? I'm going to write that down. Let's look at a few examples. So here's the first example. We have an expression 6x plus 9x. As you can see in this expression, 6x and 9x are like terms, same variables and then same powers, or no powers visible for both, right? So how do we combine them? Well, we can think this way. I have 6 x's and I need to add 9 more x's. So how many x's will I have in total? It's 15, right? 15 x's. So I will write 15x. And that's how I can just kind of like read it to myself and see what the result is going to be. But now I can also come up with a rule. Looks like when we combine like terms, what we do, we only have to add or subtract coefficients in front of the variable. So 6 plus 9, I will add that, and I'll keep I will keep the variable, right? So I just rewrite the variable, but I add or subtract the coefficient. So 6 plus 9 equals 15. And that's what I put here, and I just write x once. So that's going to be the rule. Let's try it again. 4y squared minus 20y squared. Once again, we can see that these are like terms, same variables, same exponents. So to combine them together, we need to perform operation over their coefficients. So I'm focusing on 4 and negative 20. So I need to do 4 minus 20. 4 minus 20. Now 4 minus 20 is negative 16. And that's the number I'm going to write, negative 16. And then I'll just copy down that variable, y to the second power. Like that. So I'm not doing anything to the variable or its power, right? Just the coefficients. One more example. Negative m squared plus 3m minus 12m squared. Now, what can we say about this expression? Are these all like terms? No, they're not all like terms. Well, they're all variables m. However, not all of them raise to the same power, right? So the only like terms will be negative m to the second power and then negative 12m to the second power, right? Because that's where both variables and exponents are the same. So the only two terms that we can combine here are the first one and the last one, and the one that's in the middle cannot be combined with them. Now, to combine negative m squared and negative 12m squared, I have, as in my previous examples, performed the operation over the coefficients. So let's think. Now, the coefficient of the second term here, well, technically it's the third one, right? But the second that I'm going to combine is negative 12. It's the number that's right in front of m squared, negative 12. But what is the coefficient of negative m squared? Well, when there is no number visible, the coefficient is going to be either 1 or negative 1, depending on the sign. So since it's a negative sign in front, that means that the coefficient here is negative 1. So it's negative 1 minus 12. Now, what is negative 1 minus 12? Negative 1 minus 12, minus 12 is negative 13. So that means that once I combine the first and the third terms, I'm going to get negative 13, and now I'm copying down the variable with its power, m squared. And that term that I haven't used, that I wasn't able to combine, I'll just have to copy down here, plus 3m. And that's going to be my answer. So our last example here will be negative 12x cubed plus 12x cubed. And let's follow the same rule. So the rule was first to confirm that they're like terms. Well, they are, because I have x and x in both third power and the third power. And then I have to perform operation over their coefficients. So I have to add, subtract their coefficients. So it's going to be negative 12 plus 12, right? Now, negative 12 plus 12 is 0. Okay, so since it's 0, then this is what becomes the coefficient of x cubed. So I'm going to write 0x cubed. But now, what is 0x cubed? By the way, every time when you look at the variable with its coefficient, what kind of operation is between them? Notice how they're glued together, right? So number is kind of glued to the variable. Remember that in math, it's only one operation that we can write like that with no symbols, and that's multiplication operation. So when we look at any term that has variable and its coefficient, then we need to keep in mind that between them there is a multiplication operation. But what happens when I multiply anything by 0? So technically it's 0 times x. Well, anything times 0 is 0, right? So that means that once I combine those two terms, I get 0. Now here we used same approach as before, but I said we can look kind of differently at this example. And another way to look at it is the following. If you look at the terms, you can also notice that they're opposites, right? We got 0 when we added negative 12 and 12, well, because they're opposites. But I can look at the entire term, not just the coefficient, and look at the negative 12x cubed and 12x cubed as opposites. So when we have opposite terms like that, they, in a sense, cancel each other out and we get 0. So that's going to be the result for this. So here's one last example for combining like terms. So let's combine like terms in this expression. Now, as you can see, this expression is pretty long and it has a lot of different terms. So what that means is that to combine like terms in that expression, first we need to spot them. Not all of them are like terms, right? I can already see that while they all have same different variable, the exponents are different. So let's try to spot terms that are like. When expression is long, it's helpful to somehow identify and mark like terms. So I'm going to be using different colors. So I'll start, and that's also something common to do, I'll start with the term that has the highest power. So by doing that, my answer will be written in the descending order of degrees or powers. So 4 is the highest power. I'm going to start with that. So which terms are like terms with 7x to the 4th power? Well, the rest of them that have power 4. Here's one more, right? And looks like I have another one. It's 3x to the 4th. So this time I have 3 like terms. And that's okay. I can have as many like terms as I want because to combine them would be exactly the same idea. I just need to combine their coefficients and copy down the variable with its power. So let's combine the coefficients. It's going to be 7 plus, okay, so what is the coefficient of x to the 4th power? Remember, when we don't have a number in front of the variable, it means that coefficient is 1. Coefficient is 1. Now, why we don't write it? Well, because if I put 1x to the 4th power, which is totally fine, it's not going to be a mistake if I write it, but there is no point of writing it because 1 I can easily multiply by x to the 4th. 1 times anything is that same thing, right, as itself. So that's why it's not written, because we kind of performed that multiplication and 1 disappeared. But anyway, we need to remember that that's 1 if it's not visible, but we need to use the coefficient. So we're going to add 7, 1, and here's one more coefficient, it's 3. So 7 plus 1 is 8. 8 plus 3, that's 11. So once I combine those like terms, I'm going to get 11x to the 4th power. Next, I'm going to find terms with power 4 of degree 4. Negative 4x cubed, and here's one more, negative 2x cubed. To combine them, I have to calculate negative 4 minus 2. Negative 4 minus 2, that's negative 6. Negative 6, and I'm copying down the variable with its power, negative 6x cubed. And I have one term left. As I can see, there is no like term to negative 2x, so I'll just simply have to write it down or rewrite it, copy it down. And that's going to be the answer for this example.